Okay, first thing someone's going to say is, what the hell is it doing on the floor? Well, a couple of reasons. One, it's a concrete floor, so it's cooler down there. Two, I don't have any animals. Three, there are mesh coverings over all the vent openings. So, low dust, cool area. But you can see in the corner over there, the PSU is a 1600 watt PSU, so that the power fails, there's still power to this machine. Alright. Okay, well, we're up. Now, thing is here. And let's make sure that it actually works. So, first thing we ever do when you install a new graphics card, that's right, reinstall the graphic drivers. In this case, there's specific ones that I've already downloaded. So I'll just reinstall those. Yes, I am running Windows 7. I don't like Windows 8. And no, we aren't doing Windows 10 NSA edition. We do not have access to all my emails and passwords. We don't like that. Alright, hang on while I reinstall these suckers. So what we're doing is we are just going with the graphics driver. I really don't care about any of the rest of the stuff. Physics, not important. And always do a clean install. You're saying, what? Physics not important? It's not important for scientific research. Gamers, yeah. Now I'll show you something else that we do because there's a slight difference between using this machine for gaming and using it for scientific work. Okay, in case you're wondering what happened, nothing ever goes as planned, and as I told you, ASCII's computers are notorious. It did restart, but it didn't throw a signal out, but I can remote in, and I told it to reboot, and so it's finished installing the driver, so we should hopefully see it come back up here in a minute. And as you can see, it's back up, so that's just one of those little things about ASCII's. Alright, well, first thing to find out is, yes, I know the SLI is missing. We don't use SLI in computer, sorry. We don't use SLI in scientific computations. It actually slows down work processing if you have an SLI. So, let's see if Precision X sees it. A couple of programs we run here. One of them is Process Lasso. The reason for that is, for what I use them for, these work units can take 100% of one core if you let it, and basically lock up your computer. Process Lasso prevents that from happening and forces it to break and then restart another core. So it prevents 100% usage, which will cause a lockup. Somebody probably said, well, you want 100% usage. Well, yes, but you don't want it to freeze your system. So that's one thing we use. Okay, so we do have it. And then I'm going to see if we have, I'm pretty sure we do have NVIDIA Inspector on here. Yep, there we go. Now, why do I want this? The reason we want this is because, yes, when you're gaming, you're usually in a P0 state, which is fine. You run this thing as fast as you want, overclock it, until it fails. Fortunately, for scientific purposes, when we're crunching data, or the work units, NVIDIA decided that they were going to use a P2 state for those scientific processes. And that's slower than your normal. Your normal memory clock is about 7 gigahertz. They lowered this thing down to 3304. Now, in the old 980s, they threw that all the way down to 3000, so you're only getting 6000 total. double this to get your clock speed. You can use NVIDIA Inspector to increase this value back up, though you run the risk of causing errors in your data if you do it, but we found it's pretty stable. You've been using it for a while now, and it does work. So you have to individually select each graphics card and tell it that you want to raise it up. So fly. You gotta do it for each one, so it's a little pain in the butt before you can start. But it's worth it. Sorry. Boy, it's just not going to let me do anything, is it? Alright, we'll just do it a few times. And the last one. Now, why is it important for us to get this up higher? Well, communication between the graphics card and the CPU is affected by this memory, so the faster it is, the quicker the work you're going to get done. Could I overclock my GPUs? Yeah, I can, but again, there's the problem where if you do it too much, you start corrupting your data, and you'll see that with the errors being thrown out by the work units and then returned. So, for the 980 Ti's, we found about 1.4 gigahertz is a good stable speed for them. Yes, you can go higher, I know, but that's not the point. This isn't a gaming computer. This is a scientific computer. Now, let's talk about some of the different things we run here. I run process lasso to limit. We do have a Corsair Link, which is, of course, configured for cooling that CPU. The next one is actual program manager, but in this case, Boink Manager, which actually runs the programs. And in this case, it's configured to run a program called Einstein. But Einstein really doesn't stress this computer that much. So we're going to suspend that for now. Yes, I will clean that in a second. So let's just close these out for now. Or make them small. Another program I run is Boink Task. And when it launches, if it launches, it takes a little while. It gives me a little better information about the computer, because what it tells me is it gives me deadlines, how much CPU is being used, status, also memory. And I've not configured this one for the memory, but I also like it because it gives me history and it gives me an overview of how long work units take and how they did. So over here we can see memory. And that's important because sometimes you go with some of these scientific projects and they will use a lot of memories. We had one where it was using over 1 gigabyte of memory per work unit. Unfortunately, some of the earlier cards only went to about 3 or 4, and you would run out of memory and it would cause the system to crash. So that's why we use this. Now I'm going to show you a project that does use a lot. And that's called SETI at Home. SETI at Home, yes, look at the aliens, the signals, but we're going to allow this thing to get some work units. And then you're going to see what this thing looks like. Another program I run is SIV X64. And that gives you an overview a lot of the functions of my computer. I can actually control a lot of stuff from it if I wanted to. So, what you can see here is you can see all 20 cores overclocked to 1.0. The DDR4 overclocked to 3.47. And for this computer, this is what's stable. It's stable for scientific purposes because and then you can see up here, you can see 4 GPUs and We're going to pause for a second so I can take a look at the website on this thing and see what's going on. Alright, so we're waiting for it to send me some work units. We got about 2 minutes 45 seconds. So let's talk about the board. Why did I pick this particular board? Alright, I picked this one board because it has 4 PCI slots, all of them running at 16. But that doesn't make any sense because if you know anything, the chips are either 16 or 32 lanes. The i7 says it has 40, but that's still not enough to give you 16 to all 4 PCI slots. It does this because of the PLX switch, which moves the lanes between the different PCI slots as needed in order to get as close to times 16 as possible. Anatech did a really good article on this, so you might want to read that. Even though it's a couple years old, it still applies. Why is having times 16 important for us? For computing, scientific computing, it's important because we found that on certain projects, depending upon what the CUDA was, you could have slower throughput on a times 8 or times 4 as compared to a times 16. And since we're trying to get as maximum work done in the shortest amount of time, it behooves us to have the higher PCI speed. So, alright, what you can see now is we're downloading some work units from the SETI website, and we will get an idea of exactly how much stress we're going to put on this computer here in a second as these load up. So far we're only running 4 work units. We should be able to get up to about 16 here in a minute, and that'll put a stress on this computer. Because somebody asked me, why do you want a 20 chip? You're never going to use all those cores. Well, yeah, actually I am, and you'd be surprised. This is one of 5 computers, all similar, only the 5th one is the only one that's not an actual clone of this particular motherboard. This is a 20 chip. I have a 5900 16 core and then 2 5960Xs, and the last one is a 5930K. But this is for scientific reasons why we're doing it. So what are we up to here so far? It looks like we're running, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yep, we're running 12. So as you can see, we're using about 98% GPU utilization, and I'm running about 40%. So I'm running about 8 out of 20 cores.